Professionals, we're continually looking at improving our practices and processes so that we can deliver quality software solutions to our customers faster. Key to this is getting our databases into a managed lifecycle. We're very good with our application code, or we're getting better, but we seem to not be applying those same practices to our databases. So today I'm going to show you some techniques that will enable you to improve the development and the delivery of your SQL database solutions using SQL Server data tools and the data tier application framework. That's me. So I'm going to cover three things today. Some hints and pitfalls about getting your existing databases into SQL Server data tools and Visual Studio. A look at how we can automate deployments using the DAC framework. And finally, how we can customize the build and deployment processes to make the tooling work for you rather than you have to work for the tooling. So let's have a look at what the components that I'll be talking about today. There's SQL Server data tools, which is an extension to Visual Studio. It ships with the recent versions of Visual Studio. And that gives you a thing called a SQL project. And that's where you do all your SQL source code work. We've got SQL package. That's a command line executable that manages the deployment extraction of these things called DACFx, which we'll get to in a minute. The data tier application framework, or DACFx. This is the API and the engine that manipulates the DACFx, does all the lifting for SQL package and for the SSDT, and provides quite a rich API for doing neat things. And then finally, we've got the DACPack. This is the fundamental unit. This is a build output, so we've got a build process in Visual Studio, and that builds a DACPack. And a DACPack is also a fundamental unit of deployment. A DACPack contains the full schema of your database. There's a related entity called a backpack that also has some JSON serialized data inside it. I'm not going to cover backpacks today, just DACPacks. And the arrows just indicate how the layers talk to each other. So the latest versions of SQL Server data tools and DAC framework work with Azure, SQL Azure v12 databases and back to SQL Server 2005. Visual Studio 2015 shipped with the July version of the data tools and DAC framework. I'm getting lost. But if you're going to be using any prior Visual Studio editions, make sure you upgrade to the latest version of the tooling. So let's just talk about enterprise systems. What do I mean when I say enterprise systems? Generally, as we build our solutions, we're not talking about a single database in isolation. We're talking about databases with relationships to other databases. Talking about fairly complex databases. Often we tend to refer to them as legacy. They've been around for a while. They've got a lot of things happening in there, and we're probably not too proud of some of those things. They're not perfect, but they're ours. So when we're working through tooling these things, we just need to we need to be patient with them and understand and accept the constraints and decisions of the past. So here's a typical solution. Looks kind of like the one I work with. We've got the blue there are some global databases. We've got one of those, each of those, on a single instance per environment. There's a reference database, some authorization, some customer routing, some interface stuff, blob, it's not really matter. And then we've got several horizontally partitioned or shards. And we've got, the numbers aren't quite right, 100 of these. And every one of those shards has the same schema. Okay? Should have, but there's some slight differences. So that's one of the first things we have to deal with. An enterprise schema looks something like that. Now, there are places in there where dragons daren't go, right? It's just... Sometimes I'd like to think of it more like that. Okay. So what happened when I took one of our databases and tried to import them into SQL Server Data Tools? Well, extracting a data tier application using SQL Server Management Studio gave me 16% success. 457 objects out of nearly 3,000. And 16 is rounded up, right? So HoloLens is over there if you want to go. So why does this happen? So one of the things that happens is we've got old stuff in there. We've got stored procedures, views that are referencing columns that no longer exist. Okay, we tend to have these things hanging around. Encrypted objects, they're going to be a problem for us. We can't unencrypt them, it doesn't know the keys. They're locked up in SQL Server. So when we get an encrypted object back from an extract, we get begin, end on a stored procedure, that's it. We had a case where our databases referenced that refdb, and they were the root of a whole chain or a whole tree of dependent objects, those references. So that whole tree doesn't come across. Okay. Unsupported objects for the target platform. You might accidentally try and import a database version into the wrong version of a project. Okay. So when you look at some of these issues, you're going to have to engage a subject matter. You're going to have to talk to your DBA, okay? And come up with a plan. SQL Server Management Studio 2008 had validation turned on by default. So turn validation off, get the stuff into the project, and then work out what you want to keep and what you want to throw away. Use the latest version of the tools. This isn't necessarily an issue with getting the stuff into your project, but lots of objects can be problematic for SQL Server Data Tools. When you import stored procedures, for instance, the first 1,000 go into a folder called procs1, the next 1,000 into procs2, procs3, procs4. And developers probably want a little bit more structure around those, a little bit of grouping through subfolders and things like that. So look at that aspect as well. And also having many thousands of objects affects the SSDT performance. Okay? It's going to try and build everything. So one way to deal with this is to use something called composite projects. Now these are similar to normal .NET projects in that they can reference other projects. And this can be an incredibly useful technique. So composite projects let us reference external databases, break up a larger schema into logical units. We can separate by schema or functional area. And by separating things out into separate projects, we can decrease our build times. Because if we make a change to one project, we're only going to build that project. We're not going to build the other ones. So let's have a look at composite project references. So here's my database project, and these are my artifacts, my tables and stored procedures and things. And that project can reference a DACFx, a system database, master or MSDB, or another database project. And those database project references can be same database. So this is quite cool. You've got two projects actually going to deploy to the same database. The same server, a different database, or a different server, different database. And those two there just introduce a couple of SQL CMD variables into your project, and you can set those at deploy time, and they'll resolve to wherever those reference databases are. So let's see how this works. And my laptop's gone to sleep. Second try. Okay, so I've got a solution here, and I've got 8 projects. The bold one is the main project. This is the one that's referencing the other sub-projects. I've got common there, and that's common objects, so there might be reference tables. Pretty much anything that's left inside the DBO schema, bung it in there. Do we all recognize the name, AdventureWorks? It's a reason, but I'm not going to use our databases here because I've split these out by schema. And so we've got human resources, person, production, purchasing, sales. And then I've split out the common user-defined data types as well. So if we look at the main project, excuse me, and we look at references, we can see we've got these references to the other projects. We look down here, and we've got those reference variables. These are all same database, same server, so there's no variable references there. We'll see those in a minute. So if we have a look at one of those, so one of the properties you set on a reference is this suppress reference warnings. Okay. Now I've got false there, so if I get any warnings in my referenced project, I'm actually going to get warnings. Now you might want to do that if you've got that reference project is referencing something that you don't have access to. It's going to spin up a warning, just ignore it. It's just one of those things you're going to have to try out and experience for yourself. So let's have a look quickly at adding a reference. So we can add reference there is for a SQL CLR DLL, that's normal .NET assembly. Let's look at add database references. So here's the 3 types of database reference. We can database projects in the current solution, a system database, or a data tier application, a DACFx. So the data tier application DACFx reference is quite interesting in that someone can ship you their schema. You can reference it and build your own database with those references. You don't have to have a back file of their whole database. So it might keep some people happy that the data is not transferring between development teams or companies. So here we have the that's the default, it's not the one, okay. So you can see if we have different database, same server, we get a variable for that database name. If we go different database, different server, we get a server reference as well. One interesting thing about the system databases is that depending on your project target, the version of SQL Server that your project is targeting, this will reference the master or the MSDB DACFx for that version. So there's some guidance around there that you might want to go into the folders where they live, and that's and rename them so they're a bit more obvious that you want Master 2014 or Master 2008 R2. But generally they work just like that anyway. So let's look at the main project. And we're going to look at publishing. We're going to look at what it means to publish a composite project. Okay. So if we just go into the advanced settings on the publish, and we go down to the bottom here, we've got this include composite objects. So what that's basically saying is, when I deploy this database, I'm going to include all the composite project references and deploy those as one. If that's unchecked, it will only deploy the artifacts that are contained in that single project. Okay, and your deploy may or may not work because of the references to the things. So when you're dealing with a publish, you need to make sure that you've got that set correctly. What have we got? So let's look at some of the differences between the behavior of a composite project in SQL Server Data Tools, Visual Studio, and standard behavior when we make a change at the database and want to bring that change back into Visual Studio. In a normal database project, a single database project, you make the change in SQL Server Management Studio or wherever, and you can just do a comparison between the database and the project, and you can import those changes. You can apply those changes. So let's see what that looks like. So I've already published this database. I'm just going to go down to person, and I'm going to add a new column to that table. I'm going to save that. So in our normal development lifecycle, we try things out in SQL Server Management Studio. They work, then we want to bring them back into source code, or you can work in source code down to the database, but it's a choice that you can make for yourself. So that's been applied to the database. If I go back to my project and compare the database to the source, so this is a normal SQL comparison. I'm comparing the source database to the SQL project. If I compare, hey, wait, whoa, I added a column. It's found all of these different changes. Now they're the things that it doesn't know about because we're working within this AdventureWorks project. So what we have to do in this case, and it's a little bit of a pain, is instead of comparing the database to the source project, we compare the database to the DACFx that's built by the project. So we do a project build, and we compare the schema. So we're comparing the whole schema to the whole schema. And then we've only got that. Now you notice we can't update because we're comparing to a DACFx target, not the project target. So what we have to do in this case is generate a script and then import that script to the right database project. Because where does person.person live? We have to actually tell it to import it into the right. Yeah, okay. Excuse me. So we can see that there, and most of the time you just copy that. You can cut and paste that. It's a little old-fashioned cut and paste, but if we save that out, did I save that? Anyway, sorry. You save that and then you import it into the relevant, in this case, person database. So composite projects have some trade-offs in that workflow. They're a little bit lumpy, but they allow you to get your database into the tooling, which is better than nothing. Okay, so we'll look at a different scenario for composite projects. So in this case, AdventureWorks have outsourced some of their HR functions, some of their human resources functions to an outfit called Meet Widgets R Us. And so, not really trusting Meet Widgets R Us with our human resources data, AdventureWorks themselves are going to write an interface service or something that needs a view. Here we go. To reach into the AdventureWorks database and pull out some HR information. Okay. So here, what we've got is a reference to an AdventureWorks DACFx. AdventureWorks have shipped just the schema to the development team. The development team reference that and can build their own views inside their own database. So this is going to deploy. And here's where we set the value for the reference on the publish file. And it's going to deploy to its own database, but we're going to have a new database, Meet Widgets R Us, with a view that references AdventureWorks. We can also use this technique, referencing a DACFx, to incrementally bring our systems into SQL Server data tools. So we don't have to do every database at once, right? We can just extract the reference data DACFx and reference that. Things that are slow moving, we just reference DACFx and we work on the things that we want to get our development teams working on quickly. So that was a whirlwind tour of composite projects. Let's get back to the slide. So what we've seen there is enterprise systems are not easy, they're hard. Okay, we need to do a little bit of experimentation and planning around how we're going to approach the import of the schemas into our tooling. But that composite projects are your friend here. They actually help in several scenarios. Let's move on to, excuse me. Let's move on to automating deployments. So now that we've wrangled our schema into source control, let's think about what that means. We're normally operating these days in some kind of pipeline, okay, where various names for these. Continuous integration, that's the first step. We've got our source into Visual Studio. We can build that source. We can actually have that build kick off as continuous integration build. We can run tests against that output. The next phase is continuous delivery, where we actually package that output for deployment, and then we might move to continuous deployment, where that is automatically deployed. And there are various principles, common principles around whenever we talk about these pipelines. One is that we deploy the same artifacts to each environment up the pipeline. So this is a challenge for me in terms of talking about automating deployments with DACFx, in that we need to know that each upstream environment is in a known state. And rather than doing a comparison and generating a script that's based on the differences between those, we might get tripped up with differences in the schema, in the target schema, sorry. So my preference at the moment is to, until we can get rigor around those versions of schema in each target environment, is to actually generate early on a SQL file and then deploy that same SQL file. So another principle is reliability and repeatability. So the common quote is, if it hurts, do it more often. If something hurts and you do it more often, you're going to automate it. If it's not automated, it's not reliable and it's not repeatable. So here's a typical pipeline. So we've got a developer, checks in a change, kicks off a CI build, moves to QA. Oh, there's a problem in QA. We've got 2 changes in there. So we decide to back something out. We'll update the source later, but we need to get this moving forward through UAT. So the same package is moved through to UAT, so we've missed that change. And we've got the DBA. Now the DBA is doing his job. He's just gone and changed the stored procedure for performance reasons or whatever. And then when we move that change from development into prod, and we don't double hit the thing, we end up with brown in production. So the desired pipeline flow is that changes are always deployed forward. So if we get a problem in QA, we'd make the change to resolve that problem back in dev and forward. And that the DBA, either before he makes the change to prod, he would make it into dev and move it forward, or we'd make it at the same time. But we'd have to think very carefully about changes that are in flow through the pipeline. We may need to restart the pipeline. Let's talk about drift. So drift is the measure of change to a database from a known state. So we talked about how we want to deploy the same artifacts to each upstream environment. To do this safely, we need to know that that upstream, that target environment, is in a state that's able to accept that change. So let's have a look at drift. I'll switch in a minute. Okay, so I'm in SQL Server Management Studio. And if we look at a database, we've got some interesting things here under tasks. We can extract a data tier application. We can export a data tier application. That's where the backpack and the data go. We can upgrade or we can delete a data tier application. I'm just going to quickly delete. So if I go ahead and register this database as a data tier application, and you can see a couple of things. We see the DAC instance name defaults to the database name. An application name, it can be a little bit more descriptive of what the application is. We get versioning, and we get some description that we can add as metadata. It does some validation, and then what it's doing here is creating a DACpack and registering that in MSDB against this database. And then we can run a drift report. Using SQL package, and I should have done. So target server name, target database name, and I should have chosen a shorter database name. Actually, if you all just want to look away. So what do we expect here? We've just registered the database as a data tier application, and now we're asking it to say, give us some drift. Show us what's drifted, right? Not a lot's happened, so we're at version 1.00. That's cool. So let's go back into, so I've switched databases, which is why I don't think I've got yet. So we'll make that same change. Or a similar change. And now we'll run our drift report again. So we've registered the database as a data tier application. Someone's made a change to it. And now we've asked it for a drift report. So now it says, oh, we've got an addition. We've got a SQL simple column, person.person, full name. And the SQL table person has been modified. So that's cool. SQL Server's telling us that something's changed. Big deal. Let's go back into Visual Studio. So this is a project set up to point to that Drift SQL AdventureWorks 2014 Drift database. And we'll try publishing. So the developer's not got the change, or it might have different other changes. And in this publish, we're going to say register as a new data tier application. And we've got this option here. Block publish when database has drifted from registered version. So let's try that. I'm going to publish. That's not good. Well, it is actually good. Publish stopped. The target database has drifted from the registered version. So this gives us protection and knowledge that the target environment is not what we expect. We're not going to publish this. And we can look at the drift report, and we can bring those changes back into our development environment. So that's basics of drift and database tools. So let's look at how we can automate deployment, or a couple of options about automation. So we can use the command line and SQL package. So SQL package is the Swiss Army knife of DACFx tooling, I guess. There are lots of options with SQL package. Like if you go to the main SQL package MSDN page, it's like this. So if you are going to use automation on the command line, wrap calls in the CMD file. We can use publish profiles. The same published profiles in Visual Studio can be passed to the command line, or we can use response files to gather those options up. Okay. Now the outputs from the command line SQL package.exe are just files, and they're mainly XML files. So if you're just hoping to use CMDs and batch files, you're going to need to look into those. It's a little bit awkward for automating workflows, making decisions based on drift and that kind of thing. So the next step up is to use PowerShell or .NET. So this is more flexible. We can actually reach into those files. We can actually get XML output. We can make decisions based on that. Okay. The objects we're dealing with are in the Microsoft.SQLServer.DAC namespace. PowerShell and .NET have full access to the DAC services methods and objects. Again, there are lots of options, but we've got this class called DAC deploy options, where we can put the settings in that we are worried about. So this is an example of extracting a DAC pack using SQL package.exe. So we've got an action, extract. We're specifying a target output file. We're specifying the source database name, the source server name, and then a couple of properties, /p:, they're properties, DAC major version and DAC minor version, so we can specify what version this new DAC pack is. Okay. With SQL package on the command line, you can only specify the major version and minor version as 2 integers, so it's 2.0, not a normal 4-part version. So this is a sample of PowerShell. The top 4 lines there are just a few variables. We've got the source server name, the source database name, the target file. I've pulled out the DAC framework location, just because it made the next line too long. But that's the location for SQL Server 2014. So you can move these references forward and back. Then we add a type reference to Microsoft SQL Server.DAC.dll. And we create a new object, a DAC services object. Okay, and we have to tell it which server we're dealing with. With PowerShell, we get access to the events on the process, so we can get a little bit more output if we want to. You don't have to register the event, it's just an option. And then we've got DAC service.extract, telling it the target file, the source database name. This is going to be the description that's stored in the output DAC pack, and this is the 4-part version. So we've got a little bit more control over version there. So when we compare the command line SQL package to PowerShell or .NET, they're pretty similar. Action extract, extract. Action publish, deploy, blah, 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 blah. There's a couple of differences at the bottom around backpacks, but we won't talk about those. So SQL package command lines, I said, can get quite unwieldy. So one method is to use a response file. There's very little documentation about what they look like. In fact, none that I can find. So in this case, I'm running an extract with a verification. Now I'm outputting standard error to verify.txt. If there are verification errors in this case, I won't get a DAC pack. So then I try the same options, the same response file, but with verification false. I've got what's wrong, and then I've got a DAC pack, and we can do that. Okay. And this is what a response file might look like. I've got overwrite files, true, I can specify the DAC major version, and then I can specify some properties that I want to use in this case. It's the same thing for a deploy report. Interestingly enough, you can actually put the action inside the response file. So the only command on the command line might be SQL package at response file, everything else in the response file. Keeps things nice and tidy. We can specify standard options, properties, and SQL variables. Okay, time for a little PowerShell. Can you read that? I'll go. It's very similar to the previous one. What So this is checking for drift a different way. So saying so in this case, I've extracted a DACFx when I made my previous release. Now I've made some changes, and I want to see whether the current database has drifted from that previous release. So there's my previous release DACFx, and this is the database I'm going to check for drift. I do my add type. I have a DAC package object, and I load the previous DAC package. I've got a DAC services object. Then I've got this thing called DAC deploy options. So DAC deploy options lets us specify things that we care about. One of the issues with the drift report is that it only uses the default options for the parameters. Okay? We'll get to that in a minute. So this way we can actually specify a little bit more fine-grained control about what we're dealing with. I can set a SQL command variable on deploy options. So pretty much everything that we can send on a SQL package, we can do it here. And then I generate a deployment report. And I'm getting some XML out there. So what I'm basically saying is if I've got some XML from the deployment report, there's some changes, either adds or removes. So here, we've got some changes. So we're going to actually output that, and we might take remedial action, send an email, whatever we might like to do. If we've got no operations out of that generate deploy report, we could automate the publish here. So we can get a little bit more workflow control, fine-grained stuff happening. Where are we for time? Another difference between a drift report and a deploy report is a drift report will tell you that something's changed. That full name column has been added. What it won't tell you is what action the deploy is going to take in that case. If you add a column to the end of a table, the data tier framework will just do an alter table, add column. If you add a column in the middle of the table, it's going to do the scary thing. It's going to drop all the constraints. It's going to create a temporary table. It's going to copy all the data from the table that's changed into the temporary table. It's going to drop the original table. It's going to rename the temporary table, and then it's going to create all the constraints again. And that can be bad, right? So we want to stop that. So this is going to tell us when that's about to happen. A drift report won't. Yeah, so a drift report compares using default values. You can't give it any options, right? So this means a drift report will ignore index padding, but detect changes to index options. Ignore fill factor, but detect change to other table options. It's going to always ignore ANSI nulls. If you've got a difference in ANSI nulls, you can have problems. So this might matter to you or your DBA. So my recommendation is to put some automation around deploy reports and use those instead of drift. What that does mean, though, is you are going to have to manage that capture of that state. You're going to have to extract the DACFx at the right time in your deployment. So you can compare version n to version n+1. Right. So we've seen the DAC services API. That's the one that's readily available and matches to SQL package. And that's useful for DACFx manipulations, extraction, comparison between DACFx and SQL databases, that kind of thing. So the data tier application framework, or DAC framework, or DACFx, provides API access to a lot more. Okay, so we can get access to a full schema model. So we can iterate tables, columns, and that's quite useful. So yeah, T-SQL model is the full model of the database schema. So we can use that to generate DTOs, keep our data annotation attributes up to date for column changes length in the database. We can update that. Does anyone actually generate CRUD things these days? We can generate CRUD, an audit trigger type stored procs if we want to. Then we have the namespace DAC deployment. So this is where things get really interesting. So what we can do with DAC deployment is modify the build output. We can modify the deployment plan. So when we build our project, we can put stuff into the output DACpack, or actually stop certain things getting into there in the first place. A deployment plan modifier can change the behavior of the steps that we're going to do for the deployment. And a deployment plan executor can customize the behavior of the execution. We can get a different progress, a different result output, or a log file or something like that. Okay. So there's some examples. Static code analysis during build. So we get static code analysis with SQL Server data tools. We can have that inside the editor. We can do hook some more in there. Generate schema documentation during build, or customize the behavior of the deployment plan. So lots of words. So we can use a build contributor to generate schema documentation, right? So you can supply arguments that control whether the extension runs or not. So you can, and specify the output file, that kind of thing. So a deployment plan modifier, we can modify the generated SQL based for a step. So if we get one of those big, scary SQL table migration steps, we might want to throw an exception. Bad developer, no biscuit. Right? Go sort that out, add the columns to the end of the table like you were told, right? So a deployment plan executor, we could generate a difference report, so we could actually put the capture of the version n+1 DACpack into the executor if we wanted to. So there's a lot more documentation here at the bottom. Okay. So let's have a look at a deployment plan modifier. Let's change some stuff. So I've got a solution with a database project and a deployment plan modifier. So the first thing we do when we create a deployment plan modifier is we reference Microsoft SQL Server DAC deployment, and then we extend the deployment plan modifier class. We also give it an export deployment plan modifier attribute. We give it a name, and we'll see why that's important soon, and a version. Okay. So when the deployment plan is built after the comparison or the build, okay, we get on execute gets called. We get a context in. That context contains the deployment plan that's been built and the source and target models. So we can actually do our own comparison if we want to find out exactly what's changed. Okay. So in this case, the first thing I'm doing is just replacing a deployment step. Whenever we get one of these outputs, the first thing is this file was generated by a tool, the most unhelpful comment there is, right? So I'm just going to say what tool generated this. It's not this one, right? Then we get a handle to the head of the execution plan, and we're just going to walk the plan steps, okay? It's a little awkward. There's some samples out there that make it understandable, but we basically have to find steps that are deployment script DOM steps. So DOM, document object model, these are the things that we care about. These are the things that are going to change the DOM or the schema, okay? In this case, I'm looking for things that are T-SQL scripts, okay? Create, alter, drop, okay? I use a SQL parser method to parse, actually that's my own method, just to get some information about the step. And then I throw that into my own little rules engine. So there's a few things you can do here. You can actually say, is the deployment script DOM step a alter table rebuild big scary monster? But all I do is take the SQL object for the step. I'm getting its name, so that might be a synonym or a table. That's the name of the object. Now I've just got a dictionary of those two actions. Okay, don't worry too much about that. So what it ultimately comes down to is I'm going to have a reference to, in this case, a create synonym statement. The story behind this is I've got a DBA who doesn't want me to just create synonym, okay? Our databases have some references. He wants to make sure that the configuration for the databases knows about the target, right? This is actually not made up. This is kind of, okay? So instead of outputting create synonym, I'm actually going to call a stored procedure that's going to do that validation, fix up the configuration data, and then create the synonym. And I'm using string builder, okay? There are parsing methods where you can create these things with objects and things, but anything you output from here is your own problem. Right? We're not in SQL Server, we're not in Visual Studio anymore. We're not going to get IntelliSense around this stuff. That's your SQL. If that breaks, that's fine. It's your problem. So that's essentially it. I'm going to look for a create synonym statement, and I'm going to output some custom SQL. So here's the database, and I'm going to, here's my create synonym. Create synonym, meet widgets for human resources employee, right? I'm just going to include that in my database build, and I'm going to build that database. So now my DACFx has a synonym. Actually, I can. To test this, I'm actually just running SQL package, okay? And I'll just show you what that looks like. So I'm running SQL package. I'm saying generate me a script. It's just a normal SQL package stuff. And then I'm specifying additional deployment contributors and additional deployment contributor arguments. So we can pass values to our custom deployment plan modifier from the project or from the command line. So let's debug that. So this is SQL package generating the deployment plan. So it's doing the schema comparison, generating the deployment plan. We're not messing around in there. That's going to say I'm going to create a synonym. like it's worked 3 times today. And it takes, yeah, okay. So I've set a breakpoint here just to show that we do get a source model and a target model. I'm not going to look too deeply in there. And we can apply additional configuration to, I think we can go to files based, yeah, we could go to files based on the server we were running this on. Here's the arguments coming in. So, excuse me. In this case, yes, I want to create custom synonyms, so we can turn these things on and off. If we want, you get full control. Okay. Replace the header step, occupy some roles. Hey, look. Build custom create synonym step. So I've got a statement, I've got a synonym, a create synonym statement. You just come here. And we're creating DBO meet widgets for the same database, human resources, object. Now, if I could remember where I put that. That looks like it. So this is the replacement of the header. This was created by a tool. I'm actually telling us what created this file. I'm outputting what the parameters were for that, and then all of those SQL deployment options. So this is how much control we have, how fine-grained we can get with this stuff. Right? Then the SQL command variables that you might have per environment. Okay. Actually, what we want to do is and here we are. We've got exec dbo usp create synonym. So this is doing that, and I put a little custom header, custom footer in there to tell it ship it. So we can control what the tooling wants to do.